The Mikoyan-Gurevich MiG-19, known in NATO reporting as the Farmer, was the Soviet Union's first mass-produced supersonic fighter aircraft. Designed at the height of the Cold War, it emerged from a period of intense technological competition when speed, altitude, and climb performance were viewed as decisive factors in air combat, created to counter rapidly advancing Western jet fighters and high-altitude bombers. The MiG-19 represented a critical step in Soviet aviation's transition from early jet designs to true supersonic combat aircraft. Its significance in modern air warfare lies not in continued frontline service, but in how it shaped Soviet fighter doctrine and influenced generations of aircraft that followed. 2. Origin and development history. The MiG-19 was developed in the Soviet Union by the Mikoyan-Gurevich Design Bureau. The program began in the early 1950s, with formal development starting around 1951. The aircraft first flew on the 24th of May 1952. It was designed to improve upon the MiG-15 and MiG-17, which, while highly maneuverable, were limited to transonic performance. The Soviet Air Force required a fighter capable of sustained supersonic flight, improved climb rate, and higher interception capability against emerging Western bombers. The MiG-19 entered service in 1955 and competed indirectly with Western fighters such as the North American F-100 Super Sabre and the Hawker Hunter. 3. Design philosophy and airframe. The MiG-19's design philosophy emphasized raw performance, simplicity, and ease of mass production. The aircraft featured a swept-wing configuration with a 55-degree sweep at the leading edge. Optimized for supersonic flight, the airframe was constructed primarily from aluminum alloys using conventional stressed skin techniques. No composite materials or stealth treatments were employed. Twin engines were mounted side by side in the fuselage, giving the aircraft a distinctive wide rear section. The MiG-19's clean lines, nose intake, and swept tailplane visually distinguished it from earlier MiG designs. For engine and propulsion system power for the MiG-19 came from two Timansky RD-9 turbojet engines. Depending on the variant, each engine produced approximately 5,700 pounds of thrust dry and up to 7,500 pounds with afterburner. The twin-engine configuration provided strong acceleration and climb performance, though at the cost of increased fuel consumption and maintenance complexity. The thrust-to-weight ratio allowed the MiG-19 to achieve supersonic speeds in level flight and maintain high energy during vertical maneuvers, a key requirement for interceptor missions. 5. Speed and flight performance. The MiG-19 had a maximum speed of approximately Mach 1.35, equivalent to around 1,450 kilometers per hour at altitude. Depending on variant and flight conditions, typical cruise speed was subsonic to conserve fuel. The service ceiling was about 17,500 meters, or 57,000 feet. The aircraft's rate of climb exceeded 25,000 feet per minute, making it one of the fastest climbing fighters of its era. Maneuverability at high speed was strong, though handling at low speeds and during landing was demanding, particularly due to engine response and limited flight control assistance. 6. Range, endurance, and fuel. Internally, the MiG-19 carried approximately 2,200 kilograms of fuel. Its combat radius was relatively limited, generally estimated at around 500 kilometers depending on mission profile. Ferry range could be extended to approximately 2,000 kilometers with external drop tanks. The aircraft was capable of carrying external fuel tanks, which were commonly used during operational deployments. Aerial refueling was not a standard feature of MiG-19 variants, reflecting the doctrine and infrastructure of the period. 7. Fuel consumption and operating cost. Like most early supersonic fighters, the MiG-19 had high fuel consumption especially when using afterburners. While precise fuel burn figures are not consistently published, operational experience indicates that endurance was short during high-performance flight. Operating costs were significant for the time, driven by frequent engine maintenance, relatively short engine life, and the complexity of maintaining to turbojet power plants. However, compared to Western counterparts, the MiG-19 was designed to be simpler to produce and maintain within Soviet logistical systems. 8. Avionics and sensor systems. Avionics on the MiG-19 were basic by modern standards. Early variants relied on optical gun sights and radio guidance from ground control. Later interceptor versions, such as the MiG-19P, were equipped with the RP-1 azimuth radar, a mechanically scanned radar intended primarily for bomber interception. There was no sensor fusion, and electronic warfare systems were minimal. Pilot workload remained high, with situational awareness heavily dependent on ground-controlled interception networks. 9. Weapons and payload armament varied by variant. Early MiG-19 models were equipped with 330mm cannons, typically a combination of NR-30 weapons. Later interceptor versions replaced some cannons with radar and missile capability. The aircraft could carry early air-to-air missiles, such as the K-13AA-2 et al. On external pylons. Limited air-to-ground capability included unguided bombs and rockets. Maximum external payload was approximately 1,000 kilograms. All weapons were externally mounted, as the aircraft had no internal weapons bays. 10. Stealth and survivability. Stealth was not part of the MiG-19's design. The aircraft had a large radar cross-section and no infrared or radar signature reduction measures. Survivability depended on speed, altitude, and tactical employment rather than low observability. Defensive systems were limited, with no advanced countermeasures. These limitations were consistent with the technological and doctrinal context of the 1950 South 11. Real-world service and combat use. The MiG-19 served with the Soviet Air Force and was widely exported to allied nations, including China, where it was produced under license as the Shenyang J-6. It saw combat in multiple conflicts, including the Vietnam War, Middle Eastern wars, and regional clashes in Asia and Africa. In combat, it proved fast and well-armed, but was limited by short-range and basic avionics. Pilot evaluations often highlighted its strong climb and acceleration, alongside its demanding handling and maintenance requirements. 12. Cost, production and global impact. More than 2,000 MiG-19s were produced in the Soviet Union, with several thousand more built under license in China. Unit cost figures are not precisely documented publicly, but the aircraft was intended to be economical for large-scale production. Its export to numerous countries significantly influenced global air power during the Cold War, providing many air forces with their first supersonic fighter capability. 13. Strengths and weaknesses. The MiG-19 excelled in speed, climb rate, and high-altitude interception. Its weaknesses included limited range, high fuel consumption, basic avionics, and challenging handling characteristics. Early reliability issues also affected operational readiness. These strengths and weaknesses reflect the realities of early supersonic fighter development. 14. Final verdict. The MiG-19 Farmer represents a foundational chapter in Soviet aviation history as the USSR's first operational supersonic fighter. It bridged the gap between early jet fighters and more advanced designs that followed. Though obsolete by modern standards, its impact on fighter development and Cold War air power ensures its lasting respect among historians, engineers, and air forces around the world.